Hello everyone, this is Group 3's final group project, and here is our how-to video. Here we explain each and every cell of our Jupyter Notebook file. My name is David, and in my group is joined Saxon Smith and Mark Juligan. Our first cell is just us importing our basic libraries such as NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn. And basically our main objective with this is to create a classification model that will predict whether a wine is good or a bad wine. Our features consist of fixed acidity, volatility acidity, citric acids, and a bunch more, and alcohol. Here's our classification. The wine is a good, which is equal to a 1, or the wine is bad, which is equal to a 0.
This is where I read the CSV file named winequality.csv and set it to the variable wines, and then printed the first 5 rows.
Here is our basic statistical measures, and we did this by doing the .info and the .describe functions, which are in Pandas. This gives us our mean and standard deviation values and stuff like that. Now, in this next cell, we are basically using the Seaborn libraries to make a scatter plot between all of the different columns in the data set. And this is our bunch of our graphs. And then in this next column, we basically are, we're basically creating a heat map with a bunch of different feature correlation values. Here is our sources for this map.
For this step, we set the variable data and we set it to a copy of the data set wines that we had earlier. We do this because the initial data set we want to keep untouched. We don't want to end up destroying all the data and then we don't have data. And we would also typically use this to pick columns of interest. In this case, every column is a column of interest, but in different data, you would establish set columns of interest. For this next step, we are then converting those columns of interest, such as fixed acidity, etc. And we are taking the data within that, subtracting it from the mean of that same column of data, and then dividing all that by the standard deviation of that column of data. What this does is sets them all to a universal standard unit, meaning that they're all being essentially calculated through the same thing rather than being all sorts of different numbers that can range. For example, acidity is going to have a different number than residual sugar. So we do this for the sake of future calculations. We then added the column good versus bad wines. We did this to replace the data column quality because what we found is that we were having an issue where the data in quality, which ranged from 0 to 7 for a rating of quality, was causing issues in our data. So what we did is we set the quality to be either true or false, to be a Boolean data of true or false, and then we multiply this by 1, which essentially makes it so that if it's a good quality wine or true, it's set to 1, and if it's bad quality, it's set to 0. And then after that, what we did is we took the data and we shuffled it and created a separate variable called random. We do this without replacement, because if you did it with replacement, you get repeats of data within the set, and that would cause various outliers and potential issues. And then we establish our training and test set, the training set including the first 66% of all the data, and the test set including the last 33% of the data.
After randomly shuffling for the test and training set, we indexed the features we were going to use and then reshaped them, and then printed out the shape of the X-train, Y-train, X-test, and Y-test.
For this part, we're establishing our X-train and X-test. We're setting them up for vectorization, which will be done later. So we transpose them and stack them in a vertical row of ones to help with calculations. So you establish them as a set number. This essentially applies to this next one where we establish theta as being an array of zeros. So it's essentially a stack of 12 zeros because that's how many columns of interest we have, which is then used later in the gradient descent algorithm.
In this next cell, we basically implemented the gradient descent algorithm, which will help us optimize our algorithm to find the greatest features that impact the score of the wine.
This is where we tested the model in the training set and compared the predicted and actual results. And we did the same for the test set and compared the predicted and actual results for those as well. After that, we then plotted the cost function in relation to the number of iterations, and it decreased as the number of iterations increased.
Now we want to count all of the correct and incorrect values. So basically we calculate the true positive, false positive, true negative, and false negative values. And then we also have calculated the precision, accuracy, recall, and F1 scores for the test set, or for the training set. And then we also did the same thing for the test set. And now in this next part, we basically implemented all of the logistic regression algorithms using the scikit-learn libraries. And in this next cell, we basically import the wines CVS file. And then we are adding the good versus bad wines column to this data set. And we are now assigning the 11 features of the column to these two variables, X and Y. So that whenever we implement the algorithms or the scikit-learn libraries, it will be a lot quicker for us. And now we are feature scaling the 11 features so that they are all into standard units and a bunch of other stuff. And we are just doing that by this simple thing. And then
For this next step, we're splitting the data set into the training set and test set. This was done earlier. It's with the whole test sizes. You're doing the first 2/3, second, third, and setting those. And then after that, we're essentially implementing the gradient descent algorithm, but we're doing it through the scikit-learn library once again. So you've got iterations of them, the numbers for the different columns of interest.
Using the predict function on the log model for the xtrain and xtest values, we were able to test both sets using tools in scikit.
And then finally, we got for the training set and the test set, we implemented our classification, and we ended up getting for our report for true positive, false positive, true negative, false negative, and various other things such as accuracy, F1 score. You can see all of that is done through scikit-learn. In the bottom left is where you see your true positive, true negative, various other things like that.
And to finish off our presentation, I would like to say thank you for all of us. Thank you.
Thank you.